Points. Now I'm going to speak in English because we have some colleagues from abroad that are following the workshop. So if you don't mind, I will speak in English anyway. In case there are some questions in Italian, I will be happy to reply in Italian or for any clarification. So first of all, I want to ask to the remote colleagues we are connected online if they can hear me.
Yes, very well.
Okay, thank you. Okay, thank you. So I'm happy to say that you have some very expert colleagues from abroad, like David Blackman, Christophe Morange, and others. We are connected today in our workshop. So another point is, may I ask you the permission to record the presentation?
Yes.
Okay, thank you. Now we start with the first presentation, which is from myself. It's the fish tanks of the Mediterranean, an overview. I will try to provide an overview of the fish tanks that are existent in the Mediterranean basin and what scientists did in the last decades. And we know that the archaeological sea level change in the Mediterranean is an important issue. And the first studies started around the 70s with Giulio Schmidt, who was pilot of the Italian military corps, and then with other people like scientists like Michele Caputo and Pieri that were competing with Paolo Pinazzoli. They were the first to probably to understand the relevance of the fish tanks in sea level change studies in the Mediterranean. And in time, many studies have been carried out by Fleming, Nicholas Fleming, by Kurt Lambeck, by myself, Flavien Ney, and many other colleagues that try to understand the structure, the feature, the archaeological feature, and the relevant significance of the fish tanks for sea level changes. Which are the archaeological indicators of sea level in the fish tanks? Mainly the channel systems, the crepido, the different levels of crepido. In harbors, sometimes fish tanks are located nearby harbors and quarries, like in Ventotene, for example. And it's interesting to compare the different levels from different sea level indicators to that better provide information on the estimates of sea level change. For example, in the harbors we have bowlers, the crepidos, the channels, stairs, piers, docks, slipways, and sometimes the quarries with the lower cuttings that are often submerged. Also, the iconography is an example of the National Museum in Naples that represent the fish tanks like this one. It is very interesting because now we can try to understand, to better understand the relationship between the fish tanks and the Roman buildings built along the coast and their use. Okay, the fish tanks are very sophisticated hydraulic systems that, according to Plinius and Varro, were used as holding tanks for fish culture, and were built mainly between the second or the first century before Christ and the second, and ceased the activity within the fourth or the second century after Christ. Due to the high cost of maintenance, so they were used just for a short period of time, and probably most of the activity of the fish tanks ceased during the 2nd century after that. So this structure have very special constructional element that they related precisely to the local mean sea level of 2,000 years ago, because these fish tanks, they worked, so the water exchange within the pools was driven by tides. So, so the best preserved fish tanks can provide a very precise measurement of sea level change in the past 2,000 years. And this is very important because from this information we can understand environmental changes, land movements, so the tectonic activity that displays the fish tanks in time. Dr. Anzidei mentioned Museale, in the Phlegraean fields. Most of the areas submerged due to the activity of the volcano of the Phlegraean fields. But there are many other areas in the Mediterranean, like in Greece, for example, or also in Italy, in the Ionian Islands, and other parts in which land movements displays of many meters the fish tanks. So in the Mediterranean there are many of these fish tanks. In Italy we have probably around 50 or more than 50 fish tanks have been selected. And outside of Italy, in the Mediterranean coast, even North Africa, for example, and even beyond the Mediterranean, like in India, have been recently discovered the fish tank. So this is an example. This slide shows an example of some fish tanks, like Istituto, top left, which is excavated in the rock, so ex pedra ex scisa from the latinators, or built on the coast, like Torre Astura or Ventotene in Italy, or Lambusa in Cyprus, even in Falasarna, Crete. In Falasarna, the fish tank, as well as the Roman harbour, have been suddenly uplifted during a very large earthquake in the Mediterranean, probably the largest earthquake never occurred in the Mediterranean in 365 after that, probably a magnitude 8 or around 8. So this is an example of a reconstruction of a Roman fish tank based on historical sources. This is the Museum of Alicante in Spain, and we can see 3 pools connected each other by channels, and all the pools are connected with open sea through channels. On the left we see 2 men which are moving one of the sluice gates of the pools, and we see that the fish tank is built along the shore in a promontory. So around 2004, 2003, a team of scientists started again to reuse the information from the fish tanks to understand the effect, the causes of the sea level changes estimated in these sites, and using a multidisciplinary method that included geology, archaeologists, geomorphology, and geophysical modeling, and so on, trying to better provide new information on this structure. In particular, we have been estimated the functional elevation. Which is the functional elevation of a fish tank or an harbour, for example? Is the elevation of a specific architectural part of the archaeological structure with respect to the local mean sea level in this site at the time of the construction. And the functional elevation depends on the type of structure, the fish tank, an harbour, a quarry, for example, its use, and then the local tide amplitudes, because tide actors can change from site to site, but normally in the Mediterranean is a microtidal zone, and tides are within 30 plus 30 centimeters. So it's important then the archaeological information to the identification, to identify the significant architectural feature, the use of historical sources to define the feature and functionality of the fish tanks, the age attribution, and the level of preservation. And this is a very important task to do with archaeologists, experts in the Roman age. Then surveys should be very careful because measurement, we have to take the measurement of significant markers with their uncertainties, and we need to correct the observation for tides at the time of measurements. Then the interpretation needs to take into account the local geological environment, so the lithology, the ground force stability, so the tectonic features, and volcanic environment, and the geophysical modeling try to explain the current position of the fish tanks, taking into account the climate changes, for example, with the melting of the ice sheets and the glacial hydrohystosis and seismicity as well. So this is one of the sluice gate still on site. We are in Pozzuoli, Naples. The most precise indicator is this channel system in the fish tanks. And the channel system uses some sluice gates to separate the inner basin, so the basin of the fish tank, from the open sea. And the channels were equipped with horizontal stones that defines the threshold, and with cutting the groove for the gate, for the movement of the gate, two vertical posts with grooves, an upper stone slab with a horizontal slope to extract the gate, and then the gate itself with a small holes like on the right photos. In the photos right is a sluice gate made of lead, which is here in the Maritime Museum in Pirci, here in Santa Severa. And the small holes are the holes to let the water enter and exit from the basin, but without preventing the escape of fish. So this is a sketch of the channel system of the fish tank, with the sluice gates here with holes, the walls, external walls, the capito, and inner part of the basin. And it's important to know that the sluice gates was built, the elevation of the sluice gates was planned to be in agreement with the tidal range of the local site. Okay, then we know that the Mediterranean tides are small, as I said before, and this analysis shows these plots here on the left, so which is the tidal range measured extracted from instrumental measurements of the tide gauges, which reports the tidal excursion in the Mediterranean at a set of tide gauge in Italy that is perfect in agreement with the elevation of the sluice gates. So this means that the Romans, when they built the fish tanks, they knew very well the tidal excursion side by side. Another sea level indicator in the fish tank is the crepido. So what is the crepido? It's a small, little sidewalk that runs along the inner part of the basin of the fish tanks, in which you are able to walk on without getting wet. So there are several descriptions of the Crepido. The most important are left by Pliny the Elder, Marcus Terentius Varro, and Juvenale, that describe carefully the Crepido, which is, for example, Pliny the Elder says that is a part of that margin that looks at the water, or Marcus Terentius Varro is the side of the lake of pond where ducks sit. That's very nice, this one. And for Juvenale, which is a level place on the bank of the river or the seaport or on the roadside where the beggars are begging. So this is another one. It's very funny. But anyway, don't describe these small footwalks. And this is the these are some examples of this Crepido in different fish tanks. Here the Grottace is nearby Santa Severa, Ponza Island in front of the coast of Lazio, central Italy, Torrestura and Ponza. It is very clear the different levels and the more levels of Crepido which are existent inside the fish tanks. So if you compare the structural fish tank with the historical sources, it's very interesting because it's become clear how the Romans planned and built this structure. For example, the channel system for water exchange should be protected by exterior walls to protect the basin from waves, for example, and so that the water never flood the basins, and the top of the sluice gates should coincide with the elevation of the lower level of the footwork, and so to keep a safety margin that corresponds to a position above the highest tide level. So this means that the Crepido and the sluice gates were never flooded even during high tides. So this is another example in Torrestura, and compared with historical sources, in which the basin themselves were protected from waves by exterior tall walls, so that the inner basin was like a pond, so the sea inside the basin was calm, without waves. So this is clearly visible today in this submerged fish tank in Torrestura. So when you are going to survey the fish tanks, what you need to find? You need to find the channel system, you need to find the Crepido, and you need to understand this the architectural feature and their relationship with the current sea level to understand the changes. So you need to excavate gently the channel system, so you are able to see and to read the information from the system. So in this case, on the left, there is a channel system varied by debris and sand, and on the right, it is the same channel system excavated and cleaned up by sand and debris. This is the same for the Crepido. On the left is the Crepido with the algae and the sand and debris, and on the right, the same Crepido cleaned up by sand and debris. And in this case, we are in Torrestura, La Banca fish tanks, is still visible the pavement that covered the different levels of Crepido, because this is a very well presented fish tank. So here, this is also Guardiole, Castle Novo, near Santa Marinella, so nearby the Santa Severa Castle. And it is a very important system of fish tank. In this area, you can still see the sluice gate made of lead with the holes in the bottom left photo. And the shape, the architectural feature of the fish tank is very beautiful. This is another one, Punta della Vipera, in the same area. This is another very beautiful fish tank, a very sophisticated one. Probably was not a fish tank for breeding fishes, but just for a pool for swimming, probably. Located in front of the nearby villa. And the interesting feature of this fish tank is the three long channels external to the fish tank that capture the water from the open sea and transport the water into the pools, different pools of the fish tank. And this fish tank is controlled by by complex systems of sluice gates and channels, which are still on site. And tomorrow we'll have a field trip here with a participant of the workshop. This is a point of the Punta della Vipera fish tank with the crepido. The number you see in this photo are uncorrected, so is related to a survey that we did on June 8 in 2013. But what is interesting is the top inner of the wall is about 15 centimeters below the sea level, and the elevation of the wall is about 1 meter, so that the crepido is located about 1.10 centimeters below the sea level. This time we were in the low tide, about in low tide. So on the top of the lower channels are located at 1.4 meters below the sea level. There are also cases of not valid fish tanks for sea level studies. This is the case of Lucullo and Tiberio fish tanks located in the southern Tyrrhenian, in the coast of southern Lazio, in the Tyrrhenian coast. And these two fishermen were controlled by springs, so they are not directly connected with the open sea, so they cannot be used safely for sea level, to study sea level changes. But anyway, they are very interesting because they have the same feature of the one that are located along the shore. So this plot shows some recent results of the elevation of the fish tanks, of the relative sea level changes investigated from a set of fish tanks along the coast of Lazio between Santa Liberata, which is in Tuscany, to the north, to the southern, is located in Ventotene and Formia Sarinola. So the mean relative sea level change for these fish tanks is about 1.22 centimeters. So this means that in about 2,000 years, sea level change was about 1.2 meters in this area. And there are many reasons for these changes that Kurt Lambert will explain you in the next note. And this is interesting to compare the elevation of the fish tanks for the Gulf of Naples in Pozzuoli. While for the Tyrrhenian coast we have a change of 1.2 meters, in the Gulf of Naples we have several meters, 3, 4, even 5 meters of sea level changes because of the activity of the Phlegraean fields, which is an active volcano, which is the largest volcanoes of the Mediterranean, one of the largest in the world, and it's a very dangerous one because an explosive volcano. So this is interesting. So the difference, how the volcanic activity affected the current position of the fish tanks. So from this information we can use the elevation data to model, to provide a physical model of the volcanic features. So at the Mediterranean, at the scale of the Mediterranean, when we try to compare the elevation of the archaeological sites from past studies, this one from Fleming, it was very interesting paper, but it's evident that sites are scattered above and below the sea level of several meters due to the uncertainties of the observations. While if you try to visit again, to survey again the same sites or part of the same sites, but trying to understand the functional relation of this of the archaeological structure investigated. Then most of them fall below the sea level on the, you can see from the left, from the right figure. So, with the exception of a few sites like Falasarna and Crete, which was uplifted by a big earthquake. So, and the more you go in the past years, and then the more is the deep of the archaeological structure and fitting the geophysical models. So, thank you for your patience, and this is the end. I would like to move later questions because we are a bit late. So in case of question, I will be very happy to discuss with you later. So I will leave the chair to Kurt.